Hi guys. So in this video, I will be discussing about one of the important behavioral design pattern, that is command design pattern. Okay. So from the name itself, you will get to know command means you are commanding someone to do certain activities. But why this design pattern came into picture? Why we are working upon understanding the command design pattern? So that we will be understanding in this video. So stay tuned till the end. So I will be explaining you each and everything in depth, like why, when, how, and then you will learn a lot from this. So first of all, we need to understand why we are focusing upon command design pattern. So here, if you can see with one of the example, I want to let you all know. Like here, let's suppose I'm taking a class, TV class. Okay, so TV is having certain functionalities, right? You can turn on, turn off TV, or you can change the channel as well. Okay, so these are functionalities you can do. Like you can set the channel, you can turn on, turn off TV. Okay, so there are various methods presented in it, like turn on, turn off. Okay, set channel. You can set the channel. And from main class, we can create an object of this TV class, and you can turn on, turn off, or you can set the channel as well. But there is a problem here. Can you think about what is the problem over here? There is a problem of abstraction. There is no layer of abstraction over here. So here, why you will say like why there is a need of abstraction over here? But if you still focus on it and you can try to understand, like here now the functionality is very simple. You just have to turn on the TV, turn off the TV. So at later point of time, there is a chance like some other feature or some other enhancement came into picture. Then again you have to modify the existing TV class. Again you have to modify by writing new code, new enhancement, and it violates one of the important solid design principle. Can you tell me what that design principle is? It violates single responsibility principle as well, and it violates open close principle as well. You are modifying the existing class. Okay, so it is violating solid design principles. So we should not do like this, and rather we should focus upon creating the layer of abstraction. Okay, so there is a chance at later point of time TV is coming, apart from TV, AC is coming, fridge is coming, and other electronic equipments keeps on coming. Then we have to again and again we have to modify the existing class. So it's like a tight coupling. Okay, so we should not do that. So these are the problems basically which command design pattern solves. So there is a layer of lack of abstraction basically. So at later point of time, there can be more number of steps coming, more number of electronic equipments coming. So there is a difficulty in code maintenance as well. Okay, so to resolve this problem, command design pattern came. Okay, so it separates the exact logic with receiver, invoker, and command. There will be three sections in this: receiver, invoker, and command. So receiver will be the TV part. Okay, command means there is a separate interface we need to create, like I command kind of thing. There is a separate interface which will hold the property of execution of the channel. Okay, and there should be a property of doing undo or redo feature as well. Okay, so if you are trying to undo or redo the existing functionality, it will become very much tightly coupled, and you have to modify the existing class. Okay, and it will be a little difficult as well to do undo. So if we separate the logic with respect to receiver, invoker, and command, it will become very much simple. Okay, and then there's a command class which will actually command by implementing the particular I command interface, and then we can implement the logic over there. So how we will do that? Let's understand it. So this PPT part is over. So it's basically the logic driven problem. So that's why here, if you can see, there is a TV class is on channel, is string channel, turn on, turn off. We are setting the channel and printing it like what is the channel name currently. Okay, so here you can see there is a command, I command interface with execute and undo operation. Okay, then my remote control is there. Okay, it's an invoker. Basically it invokes a particular set of data, like we are creating the stack of whatever the channel changes you did in the channel, like turn on, turn off. Okay, it's a I command interface reference. There is a constructor, there is a setter method, like what command you need, that command you need to pass over here. And then client, what will do, client will just have to press the button, and with just a press of button, client can turn on, turn off any operation that they want to do, like undo operation also they want to do. So here I am making use of stack. So first it will, what it will do, while pressing the button, it will execute the command. Okay, and after executing command, it will put it in a history. So it will create a history reference. So in that history, whatever command you are adding, it will keep on getting stacked up. Basically, it's a stack of I command. Okay. And in undo, we are checking if history is not empty, then whatever the topmost value of the stack is there, we will be popping out that. And then if we want, we can undo it as well. Okay, so this is the main operation which we are doing. So whatever the last operation we did, that we have to undo, right? So for that purpose, we have made use of stack data structure over here. Okay, so here you can see we have created a different turn TV on command, turn TV off command. Okay, so these are the things. Okay, so here it is basically a receiver end. Okay, it is basically receiving the data. Okay, so here if you see there is a TV, is turn on, turn off. Okay, so if corresponding to that, there is a separate class which implements I command interface. Okay, so it basically receives the data. So whatever data is coming over here, it will execute accordingly. Like if client wants to turn off, so it will pass the data accordingly, like execute method, and then it will turn off. And then there is a process of undoing it. So if it is turned off in the execute operation, then in undo it should be turned on. And if in execute it is turned on, okay, then in undo it should be turned off. Okay, so separate method over written method I've created over here. And then from main method, if you see, so first of all, I have created normal turn on, set channel, do darshan and turn off. Okay, so that's why it was creating a tightly coupled architecture. So if at later point of time some other features came, some other functionalities came, so it will break the existing feature, and we have to modify the TV class basically. So to avoid that problem basically, so if I show you, if I comment it out this one, and if we uncommented this part, so here if I run the code, here you can see TV is on, channel change to Doordarshan. Okay, so if I modify it, so here you can see I have added a thread class basically. So to show you, like after 5 seconds, it will do the undo operation, like undo operation. So you can modify it as per your own needs. So if I want to turn off after 5 seconds, so for that sake, I've made use of thread.sleep. I have created remote control. This is a remote control class object, TV class object. And then we are turning on the TV. We are passing the new object of this class, turn TV on command. We are passing TV class reference, and just we are pressing the button. So client should not know about actual functionality. Client should not remember what all things I have to do. Client should have one feature, that is pressing the button and undo operation. That like how we are making use of TV remote control. Okay, we are just pressing on, changing channel and turning off TV, right? So we are client of TV. So same way we have to think. The client no need to know everything, like how TV is turning on, how entire data is executing, how channel is getting changed. Client does not need to know about that. Client just to execute it by pressing the button. So press button will be called, and then turn TV on command will be executed, and based upon turn TV on command, whatever execute method will data is written over there in the turn TV on command, it will get executed. So if you see over here, execute method is there, TV turn on. So TV will get turned on over here. Okay, so just they have to press the button and TV will get turned on. So here, if you see, let me go back. So press button is there, and see here, command will get executed. Whatever command is being passed over here, it will execute. Okay, so it is I command. So it is executing the existing command, and then it will add to the history, basically stack history. Okay, so and that's why as soon as it is getting added to the stack history, so whenever the user want to undo it after 5 seconds, 10 seconds, so undo operation is TV is getting off. Okay, so here we can change it to TV off. Let's suppose the client, after seeing for a certain period of time, TV is being turned off. So the client again want to turn on TV after, let's suppose 7 seconds. Okay, so we can modify that, and you can see currently TV is turned off because client doesn't want to see TV now. But after 7 seconds, client want to see TV again. Okay, so now undo operation is done, TV is turned on. So like this, internally, the command design pattern is working. I hope you have enjoyed the process. You have enjoyed understanding this design pattern. This is very important and real-time behavioral design pattern based questions that can be asked in interview as well. So I hope you have learned a lot from it. If you have learned from it, please like, share, and subscribe my video. So we'll see you in the next video, in the next set of behavioral design patterns. So we'll see you there. So it's Devjit Roy signing off. Bye bye.